please let me revise the last class session. Yeah, Pakir, headphone please turn on. Yeah, my son, I know his style. Okay, last class, please, I need your kind attention. Once I said that I need your attention, this is really I need, okay? It's not a joke. Joke apart, I really need your kind attention. The course is very much important, and especially everyone is talking about skills and the lavish thing, the AI do this, AI do this. But how AI do, this is the course. You should know about it. Everyone says mathematics is a very important thing in AI, data science. But what kind of mathematics? This is the mathematics. Please pay attention. We studied about set of the predictors, and yeah, someone can make it full size. Do you know how to this?
Third one kare sir se use.
Sorry.
Third one go.
Okay. Thank you so much. Such a genius one. Set of predictors. In this set of predictors mean we need to predict. If we are talking about the set, of course, some things, and in these some things, first of all, features, vector. Usually we represent the features with variable because why variable? Because number of features can be changed. For example, some variable x represent the window, but in some house it can be one window, it can be two window, it can be 5 or 10 window. That's why it is known as variable. And if the one features, if I am talking about the doors, in some room there may be one door, there may be two doors, there may be three door, variable. So x2 is another. So similarly, this can make a vector basically, or you can say it's some kind of a x, or this is belong to n dimensionals. Any number, okay? Not only 2 dimension, 3 dimension. In reality, it's kind of a million of dimensions. This is the set of predictors. The role of this is a major one. The second one we studied about the weight vector. My children, we familiar the weight is the contribution of magnitude of the particular features. For example, the size of the door, it's also kind of it. Quality of the expensiveness of the door, it can be in any terms. So weight, similarly for the window, weight of the, size of the window, if we are talking about the size. In all cases, we will talk about the size. If we are talking about the quality, then weight will be lead towards the quality things. So this one, just or you can say that this one, usually the initial weight is representing to the particular unit. It can be a house, it can be some illness, or it can be some schooling thing whatsoever. So it's also belong to the n number of dimensions. Once we will have weight and features, we will apply some predictors, some functions, or you can say hypothesis, maybe linear regression or maybe linear classification. So we will score for the final decision, and this scoring, of course, this is some kind of a dot product basically in linear algebra, because weight is kind of a vector and the x features are also kind of a vector. We need to take the dot product of the two vectors, and this belongs to not n dimension, only real line, can be any number. In case of a classification, binary, 1 or 0, 2 or false, two things. In case of regression, it can be any number, maybe 10,000, maybe 10 lakh, or maybe 10 or whatsoever. Are you getting my point? So belong to the real line. So this is the one thing. However, once we know these things, what these things, set of predictors, then the problem is concerned about the optimization. And in this optimization, what we need to do? We need to determine the loss or the error between the predictor and the original benchmark. Okay, so for this purpose, loss of course will contain some. This one is the label original, this one is the features, and this one is the weight. And once we will use this, of course, with the help of this and this, we can, okay, with the help of these two, we will get hypothesis, and then we will take the difference or some of classification. Okay, so we will get the error at the level. So very interesting thing here in the optimization. The role is this: in optimization, major thing to reduce the residual. Okay, so you studied in your division case. This is some kind of an error thing. Okay, for example, if we are talking about the plus. Okay, remember in some cases, if we are very interesting thing here. If this is a graph, if I am talking some kind of a line is a benchmark, this is a label thing. Okay, some points there and some points there. This one, the point is not, basically it should near to the line, but it's not exactly on the line. Therefore, we need to, this gap is kind of a residual. And this one above the line, so it's positive. And in the situation somewhere, not exact, for example, there is some house. Sometimes house owner demands very, huge amount, extra amount comparison to the benchmark price. Sometimes someone wants to sell the house on urgent basis, the cheaper than the extra one. So in this case, this is the negative. Okay, so this one is the positive, this one is the negative. Therefore, my children, we are considering the residual in form of a scale. So it should, because negative or the positive confusion. Okay, for computing system, it's not. Basically, we need to consider some kind of a distance thing. Distance. It doesn't matter plus. It doesn't matter negative, but computationally we need to measure the length. And once we are this length. Okay, this length. It should be in form of a scale. So our cost function, usually we said for n number of examples, for some hypothesis function, okay, with respect to the label, so we say it's scale. Once we have this one, remember we are considering some kind of a, in 2D cases, okay? It should be like this. Behavior. What is this behavior? For example, this is the somehow this point, exact on the line. Once system converge completely, stable, not a big difference in comparison to the benchmark data, near to the exact price. But if, okay, in this situation, this side, it will move towards here, minima. You studied in your intermediate O level study, minima. Okay, move toward downwards. You are taking the partial derivative, okay, or the first derivative, then equivalent to 0, and then you will get some values. So equivalent to 0. Equivalent to 0 means approaches to 0. By taking a change, stepwise change. But then if going upward this side, so maxima, reaching to the maxima. Similarly, the price like this one, okay, this way. If going downward, here going to upward. For what? To meet the line, to meet the benchmark, to meet the level, given level. Given level, that is a, okay, like a perfect system. So this is what basically, this is somehow parabola. My children, forget about this. This is some kind of extra thing. Suppose this one is some kind of a x, and you can say this one is some kind of y. So you can say this one is what? X square. Could you notice?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
So
sir.
gradient descent approach. Okay, so like this. But sometimes this one is kind of a real thing, okay, not a big jump. It's accommodate the system. Please stay connected here. For example, university transport is running on a roadside, but someone may do not reside exactly on the roadside, maybe inside, okay, of some village or the street, but bus can go there and pick and come back. So there is okay, are you getting my point? Some flexibility in the system to accommodate all the residents of the town in order to, okay, bring them in the school or university. So this is the gradient descent approach, very accommodating approach. But sometimes you will consider, or you may notice somewhere, this system. This represents what? This represents basically once you are taking the absolute. Everyone should come on the roadside. No flexibility. Transport will not move inside of a town. Are you getting my point? Absolute. Exact. So the thing is this, okay, again, both the center to reach the point, but no flexibility in the system. So usually the gradient descent parabola approach, where the flexibility is existing, you can say it's kind of a residual loss, somehow very much flexible, okay, can be noticed in case of a linear regression, in linear regression system, gradient descent applied. But in absolute case, this is the robust to the outliers. Okay, for example, someone is not on a roadside, bus will not pick that person. Okay, so flexibility, no flexibility in the system. You need to make, if you want to make a robust system, then the thing will be different. Then if you want to make a, okay, accommodating the flexible system, then you will use the, which system? Parabola system, not the absolute one. As you can say that first one, okay, I will explain is the square loss. This one is basically, this one is the square loss. Square loss, if I am talking about absolute, there are two things, square loss and the absolute things. You should know in order to determine the, to minimize the loss. Okay. Once you need to make algorithm, for this purpose you need to initialize what? Weight parameter. This is basically vector from, suppose from the 0. And you need to iterate your system. For example, bus will start, okay, its journey to reach the university campus. So iteration starts from t times. Okay, you can say that like this, in this situation, start 1, 2, t times. T can be 60 minutes. Okay, will reach to take, okay, in the bus. So repeat. Basically, this is what? Repetitions. System will repeat iterations. And if t 60 means basically in the temperature epochs. Are you getting it? Once this will, for at the start bus will empty,
Yes,
but 0.
Yes.
But after, okay, picking the first student 1, then after picking again the single student 1 plus 1, 2. So are you getting my point?
Yes, sir.
Kind of the iteration of the system, it will be updated. And this updation, like this is the iteration symbol. Okay, remember this one, iteration purpose. And of course, starting from this one, this one is a step alpha. Step size, big, okay, I will explain about this our convergence, the step size. So, gradient, change with respect to what? Weight parameter. And what? This cost function, this scale, this one. Take up gradient of this cost function. This is your algorithm. So in return, okay, so you will get some kind of a, basically this is known as gradient descent. Remember one thing at this point, this m number of example is what basically is the training data. Because whatever the number of examples, basically you train the system. For example, you visited 100 houses, so your data will have the, or your system will have a data of 100 houses. That one house have these features, okay, and second house these features, third house these features. So basically this represent
features.
Yes, features belong to train. What? These are the features, these are the original label, okay, benchmark thing. Whenever we will buy anything, we will compare with the original, okay. If for example we want to buy some used product, then we will see what kind of the original. So compare how much it is cheaper than the original one, or how much it is in good quality, bad quality, whatsoever, we are comparing with it. At each example, this M represents basically this one. Because this is the features, okay, of course index, so each, it will of course will go label, then predictors will, hypothesis will take the difference with this one. Of course, what you need to get the weight parameter and weight parameter from there, then you will multiply with this, and then you will, of course, it becomes hypothesis. Then with the help of loss function, you will get the error of the loss. Of course, it is kind of a parabola or some kind of a scaled system or some kind of a absolute system. So this one is very much crucial. Alpha. It's kind of a step function. Step function playing a big role. Let me explain this. Yeah, find a quiz. Come on, okay, please. You people are ready. So suppose in case of classification. In classification, this is the origin. Okay, 1, 2, 3, 4. You consider some kind of a x, y weight parameter, or basically it is some kind of represent loss function. Of course, it can be a scaled or it can be a absolute or some kind of a binary system. So 0, -1, -2, -3, 1, 2, 3. Let me explain this. If some system, okay, less than or equivalent to 0. Last day I told you people hypothesis. Hypothesis less than 0 or equivalent to 0, it will remain at position 1. For example, in your case that you studied somewhere and you are, yes please.
सर ये माइनस वाली इस साइड पे क्यों नहीं है, लेफ्ट साइड पे? वो तो 0 से लेफ्ट साइड पे थी.
Yeah, actually I want to explain this. It doesn't matter. Vertical axis, okay, I got you want to say like this one? Yeah, it should be at 0.
Yes sir.
Yeah, I can, thank you so much, but I want to actually explain some, okay, step function. You studied about the step function? No familiar with step function?
No sir.
That's okay, no issue, it's my fault. Somehow. If I said that in this case, okay, this case, last lecture I told you some example, if the score is less than 0 or equivalent to 0, then system will become a 1.
Yes, sir.
Maybe it's a happiness case, maybe it's some kind of a cancer case, maybe it's the machine will on, okay. For example, the tube lights are on if the system, okay, hypothesis feature remain with this, okay, current is passing, so how much current is there, electricity is there, all the features are there, so how much weight current, how much current is supplying, okay, so the magnitude of the weight, so you can say that system is greater than 0 or equivalent to 0, then what will happen in this situation?
System will be happy.
Yeah, system turn on. System tube light will turn on. So what wants the this side? My child, is it okay?
Yes, sir.
Thank you for correcting. Okay, if it can be okay backward. It doesn't matter. It depends upon you how you will define it. So if the system hypothesis less than 0, this situation, then add less than 0, this less than 0, tube lights will remain off.
Yes, sir.
Okay,
Yes,
so this is known as a step function. Somewhere we need to apply the there is some function hinge loss. If I will hinge loss, this one is a simple loss function. I explained already.
Yes, sir.
Hinge loss is somehow a little bit different. I may try to explain it tomorrow, but I want to proceed it further right now. So another situation is some kind, you can say that the gradient descent approach. Let me explain this gradient descent approach. How many minutes are there, please? Ashit, could you please check?
Sir, only
8.
27 minutes, sir.
The remaining?
Yes.
Okay, so we will try to notice here this function. In the score is what basically? Score is somehow the hypothesis, okay, product of the weight, magnitude of the weight and the features. This will give us some kind of a score. As I told you, it belongs to real line. Are you getting my point?
Yes, sir.
In case of a binary classification, it belongs to true or false, two values. But in case of the regression, it will have any number, okay, on a real line. So predictors in binary classification, please, I need your, just relax, but I need your kind attention. In binary classification, sign score plus negative, kind of a decision boundary.
Yes, sir.
Decide plus or negative, okay? If you can say it's the 1 or 0 or maybe true or false whatsoever. But in case of regression, it's kind of a score. For example, the tumor cell, okay, size of a tumor cell is 60 millimeter, 70 millimeter in volume, whatsoever. Are you getting my point? Score, regression, continuous data. This two things, okay, clear to all of you? If not clear, then please let me know so that otherwise the coming thing will become very much complicated if you do not understand this.
Clear, sir.
Thank you. Correct Y. Whenever we need to get the predictor, if we are comparing the sizes, we should compare with the correct label of the sizes. This one is the label. Okay, if the weight, then the volume, whatsoever, voice, we will notice the voice intensity, unit should be remain same. Remember, predictor. So margin can be there, okay? In classification, the hinge loss, there is some margin. For example, if there is a person, okay, you can say that the tumor cell, if the this one is okay, size of tumor cell. Yeah, here you can see that the age factor. In the small, okay, baby, you can say that this small size of the tumor cell, it is enough for the telling the children are having cancer. But once the person is growing up, it may be some kind of a, okay, not a tumor, but it's some kind of, you can say that the other medical reason, blood clot like thing. Okay, not exactly the tumor, but sometimes the tumor, okay, because this is the decision boundary, my children,
Yes,
decision boundary. And if the age is, okay, like me, okay, old person, so I am having some kind of a tumor, but it is growing with the, okay, this aging. So tumor is of a bigger size, but I cannot, that's why old people could not have a wonderful diagnostic. Problem is this machine learning could not predict the system easily. Are you getting my point? This is some kind of a decision boundary set. Oh, it's a minor thing. If some whatever below this line, this red boundary, decision boundary line, considered as a benign. Benign mean nothing, no danger, not a critical thing. But upper side, this is known as malignant, life-threatening tumor cell. In this case, margin, okay, you can say that somehow doctor, even for example at this age, they just change this line. So this, are you getting my point?
in the case of sir,
Yeah.
मतलब कि age उसकी ज़्यादा हो जो उस केस में
Yes, in this case, so they said that the line shifted downward. This line shifted a little down. Margin, giving some kind of a margin. This is related to the hinge loss. Okay, it is some kind of assignment for you people. You will study it by yourself, and tomorrow you will present it. Are you getting the situation? Hinge loss thing. So there is some kind of a margin. So my children, so similarly in the residual, okay, also as well as in the binary, in both the situation you can consider this margin thing. So for example, I am here, okay, you are GPS system, map, okay, telling you sometimes guiding you on the wrong path. The problem is this, the margin situation, not exactly. Google Map leads you somewhere, okay, an awkward place, location. Situation is the margin loss. It can be improved, but I am telling you the situation. One another thing, the beautiful concept, in regression case, there is the scaled, is of course parabola, much flexible,
yes,
as I told you.
yes,
In absolute deviation, no flexibility of the system. In case, this is the regression case, continuous data case. In classification case, yeah, you will use one is some kind of a complete line shift or some kind of giving a margin. Other one is the logistic. What is the logistic? This is known as the logistic regression. Basically, sometimes it's the logistic operation, like a step function, but it's the formula of this. This is somehow g of z. Z is some kind of a, I am labeling for new variable, but formula is 1 plus e minus z. Z is what basically? This is exponent. Let me explain this. Z is basically nothing else, hypothesis function, or you can say this is this one product. But it's written where? It's written, my children, here. 1 plus e minus. Once you will have this hypothesis, okay, this predictor in this formulae, you will get a graph like this.